Hey guys, so we're moving on to the 4.2 notes in geometry, and this one's talking all about the quadrilaterals again, like the entire unit is. The first thing is finding a missing angle in a quadrilateral. First thing you need to know is that the interior angles of a quadrilateral all add up to be 360 degrees. So a quadrilateral adds up to be 360 degrees. So if they give you three of the angle measures, then what you're going to do to solve this is you're going to add them up and subtract them from 360. So 52 plus 127 plus 88 is equal to 267. And then what you're going to do is you're going to subtract that from 360 to find your last angle. So 360 minus 267 means that that last angle is equal to 93 degrees. So angle X is 93 degrees. So add them all up and subtract them from 360. Let's look at the next one. So the next one's going to talk about diagonals of a parallelogram. So the theorem states that diagonals of a parallelogram equal each other, okay? They're congruent to each other. They equal each other, okay? So when you're trying to solve for a variable and you're given the diagonals of a parallelogram, we need to, in order to find the value of x, we gotta set up the equation, okay? So since diagonals of a parallelogram are equal to one another, then I can say that 2x plus 2 is equal to 6 because it's the other side of the parallelogram. So we've got 2x plus 2 equals 6, and then we're going to solve it. So if I do my two-step problems in algebra, I'm going to subtract 2 from both sides, and then I'm going to be left with 2x equals 4, divide 2 by both sides, and x is 2. So we found x simply by setting up the equation where they're equal to one another. And then we need to find the measures of a couple angles. So it says to fill in the measures of the alternate interior angles. So notice that we're trying to find the measure of angle EAD. And if you look, the measure of angle EAD or angle EAD is this angle right here. So if I look straight, if I look on the opposite side of that line and inside the two parallel, I'll notice that this other angle is 65 degrees. So since alternate interior angles are congruent or equal, okay, then that means that angle EAD must be also 65 degrees. And then when we want to find angle EDA, which is this angle right here, EDA, then we look across from it and we also see that right across from it on the opposite sides, an alternate interior angle is 44 degrees. So that means that angle EDA must also be 44 degrees, okay? And it's important to note that they will not always be alternate interior angles. You will need to use Unit 2 and triangle rules to solve. So sometimes they won't always be in alternate interiors. Sometimes you have to do a little bit of solving, okay? So watch to see if the diagonal measures is the whole diagonal or half of the diagonal, okay? So let's try another example with diagonals and parallelograms, okay? So in this next one, it says, consider this parallelogram, use the information to find x, the measure of angle E, and the measure of angle EFH. So first, let's find x. So in order to find x, we need to set up an equation. So right now we have 2x is the length of this side, and we also have right across from it, 6 is the length of this side. So since in a parallelogram, since opposite sides are congruent, we can say 2x is equal to 6. And then when we can easily solve that by dividing both sides by 2, so x is 3. So right off the back, we found that x is 3, okay? Then they want us to find angle E, okay? So angle E is over here. And in a parallelogram, opposite angles are congruent. So if I look opposite to angle E, I've got a 98-degree angle. So that tells me that angle E must be 98 degrees. The last one that we have to solve for is angle EFH, which is this angle right here. Okay, so this one's a little bit different for solving. And you're going to have to use what you know from Unit 2 in order to solve this problem. So notice that this parallelogram is cut into two triangles, right? You've got this triangle right here in red, and then you've got this triangle right here in blue. If I look at the blue triangle, notice that I have two angle measures in the blue triangle. I have 48 degrees and 98 degrees. And if you recall from Unit 2, the measures of the triangle, the measures of all the angles in a triangle add up to be 180 degrees. So if I add 48 and 98, I get 146. And if I subtract that from 180, so 180 minus 146, I now found my third angle measure, and it's 34 degrees. So if I write my new angle measure in here as 34 degrees, look at your entire picture now and look at what it's across from. It's an alternate interior angle with my other yellow angle, which is what I'm trying to find, angle EFH. So that tells me, based off of the triangles, that angle EFH is 34 degrees. So you have to use what you know in triangles from Unit 2 in order to find the measure of that angle. Then look at the next one. We're going to talk about diagonals of rectangles, okay? So diagonals of a rectangle, of rectangles, are equal, also known as congruent, and they bisect each other. So diagonals of a rectangle bisect each other and they are congruent, okay? So they are going to give you lots of pieces of information that you're going to have to label into your diagram. So first, let's look at all the pieces of information, and we have to make sure we watch to see if the diagonal measures is the whole diagonal or half of the diagonal. It's also important to note, look at here, also important to note that the triangles inside the rectangle are always isosceles triangles, which again means two sides the same. Two sides are equal or congruent, okay? There's the congruent symbol. So all of those triangles are isosceles triangles, okay? So let's look at what it is that we are given. First, we're given that Jn is 2x plus 6. So I'm just going to label that. 2x plus 6 is this side right here. Then we're given that Ln is 5x minus 9. So this one, whoops, in blue, Ln is 5x minus 9. We're also given that angle NLK, so angle NLK is this angle right here, is 65 degrees. Whoops. I want to make that one in yellow. Okay, so first of all, we know that all diagonals in a rectangle are congruent, which means that they are equal. So we can say that Jn is equal to Ln. So let's set up our first equation. So Jn is 2x plus 6 equal to Ln, which is 5x minus 9. So if we go to set that up, I'm going to give myself some room down here. We can now solve for x. So let's do this equation down here on the bottom here. We've got 2x plus 6 is equal to 5x minus 9. So first thing I want to do is I want to get my variables onto the left side. So I'm going to minus 5x from both sides. 2 minus 5x is negative 3x. Still have a plus 6 and still have equals negative 9. And then from there, I'm going to minus my 6 onto the other side of my equation. And I'm left with 3x is equal to negative 9 plus 6 is 15. And then my last step is I'm going to divide both sides by 3. So my x is positive 5. Okay? So we found our x. That's one of the things that they wanted us to find. They found that the x was a positive 5, okay? Now what we're going to do is we're going to use that x to find Jn and the length of JL. Because notice again, what they want us to find in this equation is the length of Km, and Km is an entire diagonal, okay? So they want the length of the entire diagonal. So first we're going to plug it in, plug x back in to Jn. And if I do that, then I have Jn is equal to 2 times 5 plus 6. 2 times 5 is 10, and 10 plus 6 is 16. So I know that Jn is 16. So if this is 16 and that's only half of it, I'm going to times that by 2 to find the entire thing, which is 16 times 2 is 32. Okay, so that tells me that Km, that tells me that Km, which is one of the ones that they want us to find, I'm going to write it down here, is in fact 32, has a length of 32, because the diagonals are equal. The last thing that they want us to find here is an angle measure. So they want us to find the angle measure of angle NKJ. NKJ. So if you look at NKJ, that's this angle right here in this corner, okay? So there's a couple things that we can notice. Again, we make isosceles triangles, which means that if this angle is 65 degrees right here in this corner, that means that this angle is also 65 degrees in the other corner of that triangle, because it's an isosceles triangle. Then, from there, all angles in a rectangle add up to be, all angles in a rectangle are 90 degrees. So if I want to find that little blue angle that we call angle NKJ, then I am going to take 90 degrees and I'm going to subtract 65 from that. And that will get me my angle, because that 90 degrees is a corner and the other piece is 65. So if I subtract the two, I will get my answer, which is 25 degrees. And there are my two answers. Km is 32 and angle NKJ is 25 degrees. Okay, these take quite a bit of work and quite a bit of knowledge, but you got to use these two pieces of knowledge in order to solve it. You got to use the fact that the diagonals in a rectangle are equal to one another and they bisect one another. And you got to use the fact that they make the diagonals make isosceles triangles. Okay, so make sure you pay attention and take your time with this one. So let's actually do another example, just so you have another example under your belt here. So another example of a rectangle. First, let's label what we've got. So they give us that SU is 4x plus 2. So SU is that entire diagonal. So the entire diagonal is 4x plus 2. Okay. Then they also give us that RT, which again is the entire diagonal that goes across here, is 5x minus 7. So that entire diagonal is 5x minus 7. They also give us another piece of information, and that is that the measure of angle SVT, so SVT is this middle angle. It's hard to see because I just wrote that 2 there, and that's 62 degrees. Whoops. So that's 62 degrees. All right, so let's work with the diagonals first. If we work with the diagonals first, then remember, in a rectangle, diagonals are equal. And it says that right here. So in a rectangle, diagonals are equal. So therefore, we can say that we can set up an equation and say that SU is equal to RT. So if we put an equation over here, we have 5x minus 7 equals 4x plus 2. The two diagonals are equal to one another. And then we're going to solve for x. So the equation again looks like 5x minus 7 equals 4x plus 2, and we're going to solve for x. So I'm going to minus 4x from both sides. 5 minus 4 is just 1x, which we can just call x. We still have a minus 7 equals a positive 2. And then I'm going to add 7 to both sides. So x is 9. So the value for x is 9. We found what x was. Now look what they want. They want the side length RV, the length of RV. Okay? So remember, if x is 9 and I plug it back in, then I'm going to find the entire diagonal. But notice that RV is not the entire diagonal. RV is just half of the diagonal. Okay? So I'm going to have to cut it in half this time. So if I plug it back into the RT, so if I plug x back into here, then I get 5 times 9 minus 7, which 5 times 9 is 45 minus 7, which is 38. But then, since I only want half of the diagonal for my answer, I'm going to divide my 38 by 2 and get a value of 19. So therefore, RV is equal to 19. The second thing that they want us to find is the measure of an angle. They usually want us to find a side or a diagonal and then the measure of an angle. So they want us to find the measure of angle VUR. So VUR is over here, and we got to use the fact that they are isosceles triangles again. So if you look closely, you can see that angle 60 SVT is 62, which means that the other angle, which I'm going to highlight here in yellow, the angle across from it, according to the vertical angles, is also 62 degrees. Okay? So since it's an isosceles triangle, we know that all angles add up to be 180, but we know that the two of the angles are going to be equal to one another. So if I want to find VUR, then what I'm going to do is I'm going to take my 62 degrees and I'm going to subtract it from 180. So 180 minus 62 is 118. And then what I'm going to do is I'm going to divide that by 2 because it is an isosceles triangle. So if I divide that by 2, I now get my answer, which is 59 degrees for angle VUR. Okay? Again, lots of work, lots of scratch work. You're going to have to make sure you notice things about the rectangle. Okay? Take your time. And then to end on a more easier note, we're going to talk about the diagonals of a rhombus, which is a pretty easy concept. The diagonals of a rhombus bisect opposite angles, which means that they cut them in half. So all opposite angles in a rhombus are congruent. So they bisect them and the opposite angles in a rhombus are congruent. Okay? So for each rhombus, you got to find the angle measures. So remember, in a rhombus, diagonals bisect opposite angles, which means that they cut them in half. Okay? So if I know that I can find the measure of angle 4 because look at what angle 4 is next to. Angle 4 is next to a 44-degree angle, and it does cut them into equal parts. So I know right off the back that angle 4 is 44 degrees. I also know right off the back that angle 2 is alternate interior to angle 4, so it is also 44 degrees. Then I'm going to take into account that this is split into two triangles. So we have the blue triangle, which is up here, and then we have the red triangle, which is down here. Okay? And again, if I label this as 44 degrees, now what I'm going to do is I'm going to use the fact that I have in my blue triangle 2 angle measures, and I'm going to use that to find angle 1. Remember, the sum of the sum of a triangle's interior angles is all 180 degrees. So if I take 44 and I add 44, I get 88. And if I subtract 88 from 180, then I get 92 degrees. So the measure of angle 1 is 92 degrees. And remember, anything across the opposite angles in a rhombus are equal to one another. So that tells me that angle 2 must also be 92 degrees. And that's all you do to solve the rhombuses. In the next one, we have another thing that we have to make sure that we note when we see these, is that the diagonals make a square. Oops, sorry. The diagonals make a square in the middle, okay? So since they make a square in the middle, that means that each of these degrees of each of these angles is 90. They make 90-degree angles in the middle for those triangles, okay? So we got to keep that in mind when we're trying to find the measure of things. First of all, right off the back, angle 1, straight across from the 36-degree angle, so it must be 36 degrees. Then, if I want to find angle 3, look at the triangle that I made. If I want to find angle 3, the triangle that I made here has a 36-degree angle and a 90-degree angle. So I'm going to do 36 degrees plus 90 degrees, which is 126. And I'm going to subtract that from 180 because all angles in a triangle add up to be 180. So I know that that is 54 degrees. So the measure of angle 3 is 54 degrees. Then remember that rhombuses cut their opposite angles in half. They bisect each other. So that tells me that 54, since angle 3 is 54 degrees, angle 4 must also be 54 degrees. And angle 2 must also be 54 degrees. So angle 2 is over here. That one must also be 54 degrees because it's right across from or opposite angles from 3 and 4. And then that one's done. Okay? So again, take your time with these. It takes quite a bit of work. And as always, let me know if you have any questions. Good luck.